Section 8.4 is improper integrals. This is why we had to learn how to evaluate definite integrals by hand, because these are things we will not be able to integrate on our calculator. Now my first step is basically a rewrite. We don't like to have either that infinity or negative infinity written there, so we are going to instead rewrite it as the limit, for example, as b approaches infinity, and then I'll put that b there instead of infinity. The other thing we need to know are some limits at infinity. Now for us, the important ones are these first four, but we will occasionally see the others. So let's start with the good news, which is polynomials. If you've got 1 over x to n, where n is positive, the limit, whether it's positive infinity or negative infinity, will end up being 0. So those are going to work out pretty nicely. However, if it's e, this is where we're going to have to be a little bit more careful. So again, I've got 1 over e to n, where n is positive. If I approach positive infinity, I get 0. However, if I've got the limit as I approach negative infinity, I get infinity. So the e's are where we'll have to be a little bit more careful. But let's start out with an x to the power, since those are a little bit simpler. Now again, my first step, I'm just rewriting with a limit. It's good notation, just because we prefer not to have that negative infinity there. But once I've done that, I'm going to go ahead and integrate as I would normally. Here I use a power rule. And I am going to take a step to simplify that, just to see my problem a little bit more easily. And then I'm going to evaluate my bounds as I would normally. And here, that first term simplifies us to 1/2. So let's look at that other term. If I take the limit, I end up getting 1 over negative infinity. That is 0. But if we look up here, I have a number over x to a positive power. Basically this, I'm looking at a as my x and my power is 1. So we know that that is going to be 0. I expect that. Now, we can also use our calculators to help. So I'm going to graph that function, 1 over x squared, and we're integrating from negative infinity to negative 2. So basically this left-hand side. If you look at the left, as I approach negative infinity, it's getting smaller, smaller, and smaller. So we say that converges. That means I expect to get a number for my answer. I expect that this second term when I'm evaluating, the one where the infinity is going to end up going to, I expect that that is going to be 0. So if I remember my limits at infinity, then yes, I will get 0, but I can also use my graph and say I am expecting to get 0 there, so really the only number that matters is that other number when I'm evaluating, which was a 1/2 in this case. So I use that graph to help me expect, do I expect to get a nice number from this, or am I going to get something nasty? And we'll see what that nasty one looks like in a few minutes. Let's do another example with an x. So here, once again, that first step of just rewriting with the limit for good notation, and then I'm also going to rewrite that as x to the negative 4/3 power. So again, I'm going to integrate, I'm going to simplify, I'm going to evaluate my bounds as I would normally, and let's use our calculator to help us evaluate this second one with the actual number. I get 1 over 6. Now, this one I've got a negative number, but that doesn't matter. I'm still going to get basically that variable to a positive power. So my limit rules tell me I do expect 0 there, but this is where my graph comes in. I graph my function. Here I'm going from a to infinity, so I'm looking at this right-hand side. And again, that graph is getting smaller, 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 so I expect that it's going to converge. I expect this term where the infinity is going to go is going to turn into 0. Again, I can use these limits at infinity to confirm, but my graph tells me I expect that to happen. So the answer is going to end up being that other number, which here was 1 over 6. So I am constantly looking at that graph to try and answer for myself, what do I expect is going to happen when I do this problem? All right, we said the e's are the hard ones, so let's look at e's. So once again, my first step, I'm going to rewrite just for good notation. And then I'm going to integrate with my e to the power of a constant times x. Now again, I'm going to do a rewrite here with the e in the bottom just to make the evaluation process a little bit easier for myself. And then let's plug in those bounds so we can actually evaluate. And once again, this second bound with the actual number is the more important, and I can use my calculator to help me compute that value if I need it. Now, let's say we remember our limits at infinity. I'm going to look at this as a constant over e to some positive power, and I'm approaching positive infinity. So if I remember my limit rules, I expect to get 0 there. But let's say I don't remember my limit rules, or I'm second guessing myself on a test or quiz. That's where my picture is going to come in handy. So I graph this function. I'm going from 0 to infinity. So just like my last two examples, this graph is getting smaller, smaller, smaller. So I expect my answer will be a number. I expect that this term, where I'm going to end up getting that infinity, is going to go to 0. So again, I am constantly looking at this graph to say, am I going to get a number or am I going to have something nasty? And let's finally see, what does it look like if I don't get a number? So first of all, let's just look at the math. I'm going to rewrite as I would normally, and I'm going to integrate, I'm going to simplify. Up to here, it looks very similar to my previous example. And once again, this second term with the number, I can simplify and have my calculator help me if I need it. Now, this time, I've got a very similar graph to my previous one, but this time I'm looking at the left-hand side from negative infinity to 0. And this is not getting smaller, smaller, smaller. This is getting constantly bigger. It's becoming infinitely big. So that's what it looks like if it diverges, as if I have this huge amount of area that I can't possibly compute. If we remember our limits at infinity then, I've got a number over x to a positive power, but this time I'm approaching negative infinity. So if I check my rules, I'm looking at this one, and that one tells me I am going to get infinity for that term. Needless to say, infinity plus a number is still infinity, so I do get infinity. Now for this type of problem, we are not going to say infinity for our answer. We are simply going to say that it diverges. What I recommend for these problems, and in particular the e's, is to graph as your very first step. If you can tell that it diverges from the graph, you don't have to do any of this. You can just say, it's getting bigger, therefore it diverges. I wanted you to see the math so that you could hopefully make that connection, but since my answer is diverges, I can see that from just the calculator. Again, if I use my calculator and I see it converges, I know I'm going to expect 0 for that one term, but then I will have to do the math to get the other term. Now again, it is going to be for us just the e's that work out that way. Everything else should work out nicely. So if you've got x to a power, like we saw in these first two examples, I am going to expect that those will converge, and so I'm going to expect that I will see a 0 when I have that infinity for those two terms. And that is pretty much section 8.4.